Hello and welcome to my video for SER 321 Assignment 5 Distributed Algorithms. Today I'll show you how my distributed algorithm project works. So the first thing I'm going to do is I'm going to run the Gradle leader. So that is done with the command Gradle run leader, and then I will run the nodes, which is done by Gradle run node and the argument 6003, which is the open port. And at first I'm going to do it with a p fault of 0, which is a not faulty node. So I'm going to run the other two nodes on 6001 and 6002, also with the p fault of 0, which means it's a non-faulty node. So I'm going to run these three nodes, and then in another terminal I'm going to run the command Gradle run client, and upon running this command, it will ask me for the set of numbers I would like to sum up. So I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, and the delay in milliseconds will be 100. And then as you could see here, the leader and the nodes are receiving this information. So the client talked to the leader, and the leader talked to the nodes, and then as a result, it gave a response to the leader. So let's go through this output from the leader. So the leader was waiting for the client input, and then it got the set of numbers. And so the first thing it's doing is calculating the single threaded sum, and it went step by step, adding 1 to 2, adding 2 to 3, and it got the output of 45, which is right. And the single threaded sum is 45, and the time it took to get this sum was 989 milliseconds. And then the second thing it did was it divided it into sublists so it could do a threaded sum with using a distributed algorithm. So the first sublist for node 1 to do was 1, 2, and 3. The second sublist for node 2 was 4, 5, and 6. And then the third was 7, 8, and 9. So it split it up evenly. And then it connected to the nodes. It connected to the nodes, and then each node 1 did the 1, 2, 3, node 2 did the 4, 5, 6, and it received the results from the node on 6001 for 6, which is 1 plus 2 plus 3, and then for 15 and for 24. So it received the sublist sums, and then it did a consensus check to check 6001 port was checked by 6002 to see if the sum that the port on 6001 did was expected, and as expected, it did have the expected sum, which is verified by another port. So all nodes agreed that all the sublist sums are right, and then it gave a distributed sum of 45, which is correct. And then here we have a performance comparison, and as you can see, the single threaded time was 989 milliseconds, and the distributed time was about a third of that, which is faster. And it also says distributed time was processing was faster. And then as you can see, that is the distributed algorithm with three non-faulty nodes. And now I will do one with a faulty node. So I'm going to clear all my terminals. And I'm going to run the Gradle run leader. The first, I'm going to run 6003 with a 0, which means non-faulty. And then 6001, I'm going to run with a 1, which indicates that this is a faulty node. So I'm going to do a faulty node, and then I'll run the other one with a non-faulty node, 6002. And then I will open up the another terminal so I could run the client again. And here we go, I'm running the client, and I'm going to feed it the same set of numbers I did for the first one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a delay of the 100 again. And then let's see the output here. So it did the single threaded sum, and it got 45 again. And then for the nodes, for the sublist nodes, it split up the numbers exactly how it was before. And then we see for right here on that we got a sum of 16 from from node 1, which is supposed to be a sum of 6. So this node gave a faulty response. And so when you look through here, you could see that the consensus failed, that nodes disagreed on results. And so this is a run through with the not with a faulty node. So now we'll do one where there's only two nodes running instead of three. So I'm going to run this node 6002. I'm going to run 6001 with a 0, which means non-faulty. So two non-faulty nodes I'm going to run. I'm going to run the leader as well. So our nodes are up, and I'm going to pull up the terminal, and I'm going to do the Gradle run client command. So there's two nodes running, two non-faulty nodes, and I'm going to put in the same exact input 5, 6, 7, 8, 9, and 100. And here we can see an error collecting distributed results. So there is an error because we do not have three nodes running, so it will give us an error. And this is a quick walkthrough of my distributed algorithm project, and this script demonstrates both the successful operation of the distributed system and error handling for scenarios like insufficient nodes or faulty nodes. And thank you for watching. Bye.